Here we learn about the triangular prism. There's a picture of triangular prism. Now the triangular prism is made up of 5 faces. Out of these 5 faces, 2 faces are triangles. Here's one triangle and this is another triangle. So 2 triangular faces. So it has 2 triangular faces and it has got 3 rectangular faces. So we'll mark the rectangular faces. So this is one rectangular face, then we have another rectangular face out here, and the third rectangular face. So it has got 3 rectangular faces and 2 triangular faces. But when we draw the prism, we only draw this triangle. Here in this manner, we draw only a triangle. And the angle between the rectangular faces is called the angle of the prism. So this is marked as the angle of prism. So here we learn what is a triangular prism and how we draw it in our books. We draw it just like an equilateral triangle, and we've also learned what is angle of the prism. Here is the angle of the prism, angle between 2 rectangular faces. We'll now learn about dispersion of light. Here when white light passes through a prism, here we have white light, it splits into these 7 colors. Not 7, it could be even more, there are more than 7 colors. It splits into its different components, and this is called dispersion. So dispersion is the splitting of white light into its component colors on passing through a transparent medium is called dispersion. And this band of colors that we get here is called the spectrum. So spectrum is the band of the colored components of a light beam is called the spectrum. So you must know the definition of spectrum. It's a band of colored components of a beam. Now remember, they are not just 7 colors, they are much more than 7 colors, but we can for convenience distinguish them into these 7 colors. And how do we remember these 7 colors? You can remember this by the acronym WIPCURE. So here first you have the red, the orange, the yellow, green, blue, indigo and violet. So we use the acronym WIPCURE to remember the order or the sequence of the spectrum. Remember, red is in the beginning, right on the top, and violet is right down. So here we learn what is dispersion of light. There is a splitting of light into its component colors, and we also have learned what is the spectrum. This band of colors so obtained is called the spectrum. Here we learn the path of light through a prism. Before we learn the path of light to a prism, let us revise something that we have learnt earlier. When light travels from air, that is a rare medium, to say glass, which is a denser medium, how does it behave? So here's a light that is going to travel from air to glass. We draw the normal. If not for this interface, if not for this change in medium, the light would have continued traveling in this straight line. But because it is now entering a denser medium, the ray of light now bends towards the medium, towards the normal. So it bends towards normal and its speed decreases. This is the two things that happens when light enters from a rarer medium to a denser medium. Now what would happen if light enters from a denser medium, like from glass, which is dense, to air, which is rare? So again we have here the light, and this is the normal. If not for the change in medium, the light would have traveled in the straight line down. But now it is encountering a rarer medium. So the light bends, and it bends away from the normal. So two things happen here. The light will bend away from the normal, and speed will increase. So we need to keep these points in mind when we discuss the path of light through our prism. So here's a prism, and we have light that strikes the prism. Right? The light is at the interface. Let us see how it behaves. Remember, the light is now entering from air to glass, from a rarer medium to a denser medium. Normally it would have gone straight down this path, but now since it encounters a different medium, it's going to bend, and because it is entering into a denser medium, it is going to bend towards the normal, so it will go straight down here. Now again at this point it encounters another interface. Now it is entering from glass to air, from glass, denser medium, to air, which is a rarer medium. And when it enters from glass to air, this is what happens. It will move away from the normal. So it will move now in this direction. So here is the incident ray, and this is the emergent ray. Now what would be the angle of deviation? Here this was the original path of the ray, and now this is where it has bent. So this angle between the incident and the emergent is called the angle of deviation. So here we have angle of deviation. Now once again it's clearly shown the angle of deviation. The light travels in this manner, then it would have originally gone in this, then it deviates. So this angle between the emergent ray, I'll put them in two different colors. This is the emergent ray, and here is the incident ray. The angle between the emergent and the incident ray is called the angle of deviation. So this is the incident, and here is the emergent. This angle between is angle of deviation. So if we were to define the angle of deviation, is the angle between the incident ray and the emergent ray is called the angle of deviation. Now if the question comes to draw the path of light through a glass prism, this is the figure you need to draw. So first you have to draw the prism, of course. You've got to mention now PE is the incident ray. Then we have EF, which is the refracted ray, and FS, which is the emergent ray. We need to mark the angle of the prism. This angle A is the angle of the prism. Next, the angle between the normal and the emergent. This angle I is angle of incidence. You also have to mark the angle of refraction, and here is the angle of refraction. Between the normal and the refracted ray is the angle of refraction. Then the angle of emergence. Here is the angle of emergence between the emergent ray and the normal. This is the angle of emergence. And the last angle of deviation is the angle between the original path and the emergent ray. This angle here is said to be the angle of emergence. Here, this D is angle of deviation. So all these 8 things you need to mark in your figure. So that is refraction of light through a triangular glass prism. In this slide we will learn why does dispersion take place. What is the cause of dispersion? Dispersion takes place because light behaves, the different components of light behave in a different manner. Now when it comes to blue light, here we see blue light, it gets refracted or it bends, and the bending of blue light is maximum, is much more. Here is the angle of deviation of the blue light. So here I am coloring the angle of deviation of the blue light. But when we see the red light, it doesn't deviate as much. Here we have the red light, and here's the deviation of the red light. So when we go back, we find that the deviation of red light is much less. The red light deviates less while the blue light deviates more. If we put both the pictures together, we see here is the deviation of the red light, and this is the deviation of the blue light. So blue light deviates much more than the red light, and hence the different components now split up separately. When we write the cause of dispersion, we write blue light deviates much more than a red light. Red light deviates less, and blue light deviates more. Another point to remember is that blue light travels slowly, speed is less of the blue light, while the red light travels much faster, speed is greater. Speed of blue light is less than the speed of the red light, and this again goes because of the wavelength. The red light has large wavelength, while the blue light has a very small wavelength. So you could write this in your answer, the cause of deviation: blue light deviates much more than the red light, and the speed of blue light is less than the speed of red light. The wavelength of blue light is less, the wavelength of red light is more, and hence the different components of light, they break up when they enter a glass prism. So in the earlier slide we saw the cause of dispersion was because of the different angle of deviation. The red light was least, and when it came to the blue light, the deviation was much more. So if I ask you the question, which light has maximum refractive index? Maximum refractive index. Now remember, refractive index is the extent of bending. Now who bends maximum? And that is violet. Violet bends maximum. So violet, the refractive index of violet is maximum. and who's got minimum refractive index. And minimum refractive index will be red, because red bends the least. But red has maximum speed. Violet bends the most, but it has least speed. In this figure 1, what do we see? We see that when white light enters or strikes a prism, it splits up into the 7 colors, or into a number of colors. Here dispersion takes place. But if we keep another prism, an inverted prism, and it's allowed to pass through this inverted prism, the 7 colors or the different components combine again and form white light. This phenomena is called recombination of the spectrum. Recombination of spectrum. When the different colors of the spectrum combine and give white light again. So to go over this again, first we have white will then break up into many components, and this is called dispersion. The many components then combine again to give you white light. This is called recombination of the spectrum. Here's yet another picture of the recombination of spectrum. So we have the prism. The first prism brings about dispersion, while the next prism, here we have the other prism, that brings about the recombination of the white light. This recombination of spectrum was observed by Isaac Newton. Now when the light broke up into 7 colors, here we have when light broke up into the 7 colors, he thought if we kept another prism, it would break up further into more colors. But to his surprise, when he placed another prism, inverted prism, he found that the colors recombined to form white light again. This was a proof that white light was made up of many different colors. But for recombination of spectrum, there are certain conditions to be fulfilled. Both the prisms should be made of the same material. They should have same optical density. Second, they should have same angle of prism or equal angle of prism. And third, their bases should be parallel. Should be parallel to each other. In other words, one of the prisms should be kept inverted. Then the spectrum will recombine. So if we were to ask what is recombination of spectrum, is when the different colors of white light combine back again to give you white light. It was first discovered by Isaac Newton. Here we learn the formation of the rainbow. Now the formation of the rainbow is because of dispersion of light. The splitting of light into different colors. And the dispersion is carried on by these raindrops which are in the sky. So the sunlight that comes and falls on these raindrops, it disperses, it brings about a dispersion into these 7 colors. So each raindrop will bring red, and then you'll have the blue and the green in between. So each color disperses the light, resulting in the rainbow. So here again there's another diagram which you need to draw in your exam. So this is the sunlight entering the water droplets, and at this position you will have dispersion taking place. This, as it enters, there will be dispersion, splitting in of the light. Then the light then continues, it breaks up into these different colors. Here at this point it is reflected. Here at this point there is reflection taking place, internally reflected, and once again the light then travels out and is dispersed. So a rainbow is formed because of dispersion of light. And who brings about the dispersion? It is the raindrops. So let's read. A rainbow is a natural phenomena, natural spectrum. It's a natural spectrum, appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is formed in a direction opposite to that of the sun. This is an important point to remember. It is formed in a direction opposite to that of the sun. The water droplets act like prisms. It is the water droplets that act like prisms. They refract. Here is a refraction at this point, and disperse the incident light, reflect it internally. Here is a reflection that takes place internally. Reflection, and finally a refract again. Here is a reflection again. So I put it in. So here there is, first it refracts, then reflects, and refract again. When it comes out of the raindrop, due to the dispersion of light and internal reflection, different colors reach the observer's eye. So we have the color split into many components. So what reaches our eye are different components, and hence we can see the rainbow. So you need to write this entire answer for the formation of rainbow. You need to mention the word dispersion, water droplets, that the light when it enters, it first disperses or it gets refracted, it reflects and refracted again into different colors.